Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Tepak Maputsani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12s, in today's lesson, we are focusing on our paper 1 revision. We are completing the paper now, and we are going to focus on the two last topics, which is differential calculus and our probability. Right. Now, as we prepare for our prelims, this is what we're supposed to do. We're supposed to know the structure for a fully-fledged paper 1, and we are going to focus on the topic of differential calculus, and we are also going to focus on the probability. Now, grade 12, this is the structure that we're supposed to know for our paper 1. We know that we are having 6 topics, and we are going to focus on differential calculus, which is weighing around 23% of our paper, which is allocated around 35 marks in our paper 1. It mostly occupies 3 questions, which is question 7, question 8, and question 9. And we're also going to look at the concept of probability. The concept of probability, it weighs 10% of our paper. It is allocated around 15 marks of our paper 1, and it is our last question, so that is also is mostly found in question 10. Now, grade 12s, we have an activity here, and for this activity, grade 12s, I will give you 20 minutes to complete question 7 from Free State, September 2024, and your 20 minutes starts now. Welcome back, grade 12s. Let us now focus our attention to this question 7 from Free State. We are going to look at 7.1. 7.1 reads as follows: determine f prime x from the first principle if it is given that f at x equals to -1 plus 4x squared. What are we given here? We have to look at this one. They said from the first principles, and remember, grade 12s, we only utilize the first principles if the question says we must use the first principles, right? So that's very much important for us to note. Now, to work with the first principles, we're going to work with the first principles formula, and we'll always advise you to say start by copying or working with the top part first. Remember, our first principles formula from the formula sheet is as follows. It's f prime x with limit h approaches 0. Then we have f at x plus h minus f at x all over h. So the best way to work with this problem is to work with the numerator first. And when you're working with the numerator, we can nicely work with this part, work with this part, then work with the whole in the formula. So let's start with the numerator, and we're going to start with the first part of our numerator. Then we're going to say f at x plus h, meaning whenever there is x, I am going to place x plus h. You can see there's x squared here. So in that position, I'm expecting x plus h, and the x is squared. So the x is going to be squared nicely there. So I substitute and say f at x plus h equals to -1. There's no x there. You can proceed and say plus 4x. Now in that space of x, I substituted our x plus h, and our x squared was all squared. Then all of the x plus h, as it is now representing our x squared, it is all squared. Then we can now simplify and expand that part. We are going to remain with -1 plus 4x squared plus 8xh plus 4h squared. And we are going to check, do we have any like terms? No, there are no like terms. So we are going to proceed from here. Then as we proceed, we are going to now work with our limit in this case, and we're going to now subtract our f at x at the top. So we have f at x plus h. We are subtracting the f at x right here. Then as we do that, we are going to remain with x 8 plus xh minus 4h squared. But before we do that, let me just continue with this a bit. I can actually look at f at x plus h minus f at x as a unit, and this is how I'm going to look at it. I'm going to say -1 plus 4x squared plus 8xh plus 4h squared. Okay, let's just start afresh so that we can get enough space. So I will take the whole part at the top and say I will now subtract the f at x immediately here. So as I do that, I'm going to have negative 1 plus 4x squared. So this is me saying subtracting f at x. So I'm going to do it here before I can get it here. Right. As I do that, I'm now going to remain with the following at the top. I'm going to have negative 1 plus 4x squared plus 8xh plus 4h squared minus or plus 1, because the negative and negative is going to give us positive. Then I say the negative 4x squared. At this step, remember, this with the squared must fall off and the constant must also fall off. But remember, we are checking that it's falling off. Then we are going to remain with 8xh plus 4h squared, which is what we are having right here. So it's very important that we can simplify all of this part separately. Even if you do it here, you are still not going to have any issues. Right. Then from here, what I can do is the following. I can now factorize the top part and take out h as a common factor. Then I will remain with, you can see h exists here and x exists on the second term too. I remain with 8x plus 4h all over h, because it was 4h squared. Then I know the h and the h will now divide out. I will remain with our limit. As h approaches 0, I have 8x plus 4h. Remember, I am keeping my limit because I haven't substituted by h equals to 0 yet. If you omit this, you are going to be penalized. You need to be very, very vigilant there. Now that I have substituted my h is equals to 0, because we are approaching 0, so it's 8x plus 4 into 0. Then 4 plus 0 equals to 8x, because this 4 plus 0 will now be 0, and 0 plus 8x gives us 8x. Then our f prime x, it gives us 8x. Let us look at question 7.2. 7.2, we are looking at the rules of differentiation. Here we are saying, let us work nicely there with our power rule. When we are working with our power rule, remember the first step. The first thing that I'm going to check is the following. I am going to check, do I have a square root or a set? There's no set, so we are fine, check. Second part, do I have our variable that I must differentiate in with regards to, because I'm differentiating with regards to dx as a denominator? No, I don't have it under a denominator. Now the third step is to now check, do I have brackets? Yes, I can see that 2x cubed plus 5, it is all squared, so it's repeating itself twice. So I have to expand on that part. When I expand on this part, I'm going to have 2x cubed plus 5 and another 2x cubed plus 5. Then I'm going to get 4x to the power 6 plus 20x squared cubed plus 25. Then I can now differentiate. Then I can say 4 times 6, I get 24. Then I say minus 1 there, and I'm going to get 24x to the power 5. Then I can say 3 times 20 is equal to 16. Then I say minus 1 at the top. Then I get 60x squared. Then from here, what do I see here? The 25 is going to fall off. 7.2.2, it says, we are looking for dy over dx, so we are still remaining with our rules of differentiation. And we are told that y is equal to 3x squared, or 3x to the power 4 minus 7x plus 2 multiplied by cube root of x squared. Now, what is the first thing that we're supposed to do here? We are supposed to proceed with our checklist. The first thing, do we have a set? Yes, we have a root. Okay, we need to work with that. Do we have a variable that we must differentiate with respect to as a denominator? We can see that. Then we don't have brackets. So we are going to do two things. We are going to make this a numerator, and we are going to convert this into exponent. So we need to convert this into becoming an exponent. Then what we do from here, this is going to go at the top. It's going to have a negative x to the power. It's going to be x to the power negative 1. Then when we now work around this, this becomes our numerator. So it's going to be x is to 2 to the power 3 multiplied by 2. Now that we have our equation in a form that is we can differentiate, we can now find out our dx over dy. We can say 3 times 4 is equal to 12. then minus 1, we get 12x to the power 3. Then you say negative 1 multiplied by negative 7, it gives us positive 7. Then we can say minus 1, the negative 1 give us negative 2. Then we can say 2 over 3 times 2, we get 4 over 3. Then we can say minus 1, we get negative 1 over 3. Right, let us look at 7.3. 7.3 reads as follows. Determine the coordinates of a point on a curve of x of y is equal to 2x to the power 2 plus 3x plus 1, where the tangent at a point is perpendicular to y plus 5x is equals to 4. Okay, so what are we told here? We are told the following. We have a curve, and we are told that we have a certain tangent. So tangent is a line that is going to move. So at that curve, at that point, we have a tangent, and this tangent is perpendicular to the line. So we can have another line here. It's perpendicular to the line y is equals to y plus 5x minus 4. And we are looking for the coordinate of this point. How are we going to find the coordinate of this point? So we are going to do two things. We are going to equate the gradient of the two. So we're going to find the gradient of this line, which is that line perpendicular there. So that is perpendicular to that point. And we're going to find the gradient at a point where we're going to use the first differential. So we are going to equate the first differential and the gradient, because those are the two gradients. And when you equate those two gradients, they're going to give me the point of intersection. So we can see that we're looking for the gradient at the point and the gradient perpendicular. We are going to equate the two. They're going to give us what? The coordinate at the point, because we have two. It's more like we have two functions intersecting at one point. We are using simultaneous. So from our line, which is perpendicular to that line there, we are going to have it as y is equals to, we write it in the standard form, y equals to negative 5x plus 4. But we are told that this line is perpendicular to a certain line at that point. So m line multiplied the m tangent is equals to negative 1. Why? Perpendicular lines, when you multiply their gradients, they will give you negative 1. Thereafter, we have the line, the gradient of line, because remember, this is written as y equals to mx plus c. Our m in this case is negative 5. Then you can divide by negative 5, and mt is going to be 1 over 5. So we already now find that this is 1 over 5. Now, to get the point, remember this is now intersecting with our curve at this point, but we are intersecting with its gradient at that point. So it is a tangent at that point. So we're going to find the first differential of our f at x, which is our y. Oh, it's y prime actually, not f at x, it's y prime. Right, then our y prime is equals to 4x plus 3. So we're going to equate the two to find the point of intersection. So equate the y and the and our tangent. Then we're going to solve for our x. When we solve for our x, we get our x to become negative 14 over 20. Right, now from getting our y, x equals to negative 14 over 20, to get the corresponding y value at that point, remember we already found the x value at that point. What do? We substitute that x equals to 7 over 10 when you simplify it further here, because 2 both into both sides goes into 14 7 times into 20 10 times. Then we are going to now substitute x is equals to negative 7 over 10 in the original equation, which is the curve there, or which is our parabola there. Then we're going to say whenever there is x, I put in negative 7 over 10. Then I get my corresponding y value as negative 3 over 25. Then that is the point that is found there, which is negative 7 over 10 is to negative 25 over 5. Now grade 12, let us look at question 8. So for this question 8, you are given 20 minutes to complete this activity, and your 20 minutes count starts now. Welcome back, grade 12. Let us look at question 8. 8.1, they tell us the given the equation of the cubic function f is given as f at x equals to negative 3x cubed plus 15x squared minus 21x plus 9. Determine the x and the y intercept of the graph. Now, let's start with the x-intercept. X-intercept, we're going to let our y to be 0. From our equation there, we let our y to be 0. Then we need to factorize a third degree polynomial. And we're going to use our remainder theorem. Then how are we going to do this one? Right, we are going to do this one by the following. We are going to check our factor. And our factor, we find that our factor is x is equals to 1. So x equals to 1 is our factor. So x minus 1, it is the factor that we're going to work with. From them, we take the coefficients of our standard, which is negative 3, positive 15, negative 21, and positive 9. Right. Now, what we do from here is the following. We're going to drop the negative 3. Remember, when you go down, we add. So we're applying that factor remainder theorem. We're going to say negative 3 times 1, we get negative 3. Then 15 plus negative 3, we get this one is going to be our 12. We're going to get positive 12. Then we're going to say 12 multiplied by 1, we get positive 12. Then positive 12, we're going to say negative 21 minus 12, we get negative 9. Then negative 9 times 1, so we're going there, we multiply, then we add when we go down. Negative 1 multiplied by 1, we get negative 9. Then negative 9 plus positive 9 plus negative 9, we get 0. Now, we know that when we factorize, we are going to have x minus 1 in the first bracket. In the second bracket, we take the coefficients. It's negative 3 x squared plus 12x. So we're taking this coefficient minus 9. Right, let's proceed. Then when we have fully factorized that, we get x minus 1, which is our factor, into negative 3 x squared plus 12x minus 9. Then we are going to factorize both this bracket again. We're going to apply the zero factor law. When we apply our zero factor law, we can now see that x minus 1 equals to 0, or here it's going to be, we divide by 3, negative 3 throughout, we get x squared minus 4x plus 3 is equals to 0. Because 12 divided by negative 3, we get negative 4, and negative 9 divided by negative 3, we get positive 3. Then we can factorize the second part. There we get negative 1, it's x minus 1 equals to 0, or x minus 1 and x minus 3 equals to 0. X minus 1 and x minus 1 are the same. So I will only take 1 x minus 1. I say x equals to 1 or x equals to 3. Then the y-intercepts, so our x-intercepts are 1 and 0 and 3 and 0. Our y-intercept, we're going to say we're going to let x equals to 0. Whenever there is x, I place in my 0 from that, or y just equals to the t. Then we're going to have y is equals to 9. Because this is going to be 0 plus 0 plus 0. Then we get 9. Then our y-intercept is going to be 0 and 9. Then the 8.2 reads as follows. Determine the coordinates of the turning point of f. How do we find the coordinates of the turning point? To find the coordinate of the turning point, we know that the first differential must be equated to 0. Right, then we're going to find the first differential. Our first differential we get is 9. So 3 times negative 3 going to give us negative 9. And that minus 1 is going to be negative 9x squared. Then we go to get 15 times 2, which is 30. Then minus 1, we got 30x minus 21. Then the 9 falls off when we differentiate in them. Then we can say the first differential we got, we equate it to 0. Then we go to factorize. The left hand side, we can take out a common factor. So we can divide by 3 throughout, because negative 3 throughout. Then we can factorize our trinomial. We get the first bracket is 3x minus 7. And our second bracket, we get x minus 1. Then our x is equal to 7 over 3, or our x equals to 1. Thereafter, we're going to substitute both of these x values separately to get the corresponding x value of y value of x over x equals to 7 over 3, we're going to substitute that into our original formula. Whenever there is x into our original, which is the one we're working with here, we now place in 7 over 3. Then our y is going to give us 32 over 9. Then the first turning point, so this is turning point number 1, it is 7 over 3 and 32 over 9. Then the second turning point is going to come from the x equals to 1. So the corresponding y value for x equals to 1, we substitute x equals to 1 into our original formula. Then we get our y is equals to 0. Then our second turning point is going to be 1 is to 0. Now 8.3 reads as follows: sketch the function of f indicating all the intercepts with the axis and the turning point. Remember, we are sketching this and we are showing all of the points of interest. Right, our x-intercept was 0, 1 and 0 and 3 and 0. We found them from the previous questions. And our y-intercept was 0 and 9. The turning points are, turning point number 1 was 7 over 3 and 32 over 9. And our second turning point was 1 and 0. Then we can see that our a is negative 3, so our a is less than 0. So it must start by decreasing and increasing and decreasing. So it decreases and passes the y-intercept there. The turning point, it is going to be what? Our x-intercept. Our turning point is going to be 1 and 0. And the x-intercept is also our turning point. So it's going to turn at that point. And our second turning point, it is 7 over 3. So this is TPU number 1. This is the second turning point. And this is the x-intercept also. And this is our second x-intercept. So that is our function as sketched there. Now let us look at 8.4. 8.4 is as follows. It says, for which values of x is f prime x greater than 0? What are we supposed to do here? We are supposed to find f prime x is equals to negative 9x squared plus 30x minus 21. And we are saying now this is greater than 0. And when we are working with a parabola here, because of the coefficient or the degree of x there is to the power 2. Then we factorize the left hand side. We are going to have our critical values. Our critical values, remember, these are the points we are going to plot on our basic parabola. For our basic parabola, it's face down, it's negative, so it's going to be facing down. Our x-intercept, it is 7 over 3. And the second one is x equals to 1. Right. Then, the 7 over 3 is small, it's bigger than 1. So just made that mistake. Right. Then when you plot them, remember it says greater than. So where is it greater than? It is greater than at the top there. So greater than is at the top. So, or where it's positive, it's here. This is negative, this is negative. So it's between 1 and 7 over 3, which is the top part, which is this part right here. So we work with an inequality. So x is found between 1 and 7 over 3. Right. Now let's look at 8.4.2. For which values of k will f at x equals to k have exactly 3 different roots? When are they going to have 3 different real roots? So we are going to look at line k as a function on its own, as a line. So it's a straight line like that. Then what are we going to do? We are going to check where is this line cutting our f at x 3 times. Where is it doing it? Because we're looking for 3 real roots. Right, where is cutting it 3 times? We can see here it's going to cut it once. If our line k here is going to cut it once. But between here, how many points does it cut line k? This is line k, remember? It's 1, 2, 3. So it's 1, 2, 3. So that is what I'm looking for. And as long as you move between this point, which is 39 over 9, because our k we are looking concerned with the x y values, and the 0 here. So k can move between 39 over 9 and 0 only. So those are the points where it's gonna cut 3 times. After 0, it's once. Before 0, it's going to be once again. So even if I draw my line k here, It's gonna cut at this point, that point, and that point, continuing until 0 there. So we can see that when we get here, it's going to be 1 point. You can see that it's going to be included. Here also is going to be included because it's going to cut only once and once there. So its k can be found between 0 and 39/9. So that is where our k is going to give us 3 real different roots. Now, let us look at question 9, grade 12. And for this question, grade 12, I will give you 10 minutes to complete this activity. And your 10 minutes starts now. Welcome back, grade 12. Now, let us look at question 9 from Free State 2020, September 2024. At a price of 400 per bag, 200 bags were sold, and for every 200 increase in the price of the bags, 4 fewer bags are sold. At what price must the bag be sold to maximize the revenue? Okay, interesting. So we have two scenarios here. We have the 400 per bag, the prices, and we have the units. Okay, so the units, I'm going to make it like that. So we are going to start by looking at the price. And the price, we are saying there is an increase of 20 of the bag. So there's an increase of 20 for every bag in this case. So what we're going to say, we're going to say let X be the number of X of the 20 rand increases in the price. So as the price increases, so it's going to increase by the variable X. So now when you look at the price is going to be the 400 plus the 20, that which is our increase, 20 times X, because this 20 rand is going to increase by the X as a variable. So that is our price. And the quantity, which is the units we've sold, it is 200 units. However, they said 4 fewer bags are sold. So it's going to be minus 4X, because these fewer bags are going to change as long as for every 200 units that we're selling, 4 are now 4 fewer bags are sold. So we are going to check how much for every 200, 4 fewer are sold. So we're going to subtract 4 multiplied by X. Then our revenue is going to be price times the quantity. So our price is 400 plus 20X multiplied by the quantity, which is 200 times 4X. Then we can distribute the two brackets. We get our revenue is 80,000 plus 2,400 X minus 80X squared. Now, this is our revenue. This is the first part of our optimization. Always find the equation that represents the scenario. Now, let's go and answer the question. They say, at what price must the bags be sold to maximize revenue? Remember, the word maximum or maximize or minimize, it means we are going to do what? Differentiate and equate to 0. So every time under optimization, maximizing and minimizing, we're differentiating to 0. Then to maximum, we're going to say DR, because this is our revenue. So we're going to say differentiate our revenue with respect to X and equate it to 0 to get the maximum value, or to maximize our revenue. So when we differentiate that, the 80,000 is going to fall also as a constant. Then X, there's 1 here. 1 times 2,400 is 2,400 minus 1. Then X to the power 0 is 1. So 2,400 times 1 is 1. It's 2,400. Now we are going to say 2 times 80 we get, or 2 times negative 80 we get negative 160X, because this is going to be minus 1. Thereafter we can solve for X. Then our X is going to be 160X is equals to 2,400, and our X is going to be 15. But the question said, at what price? Then we can substitute our X into the price. Then we get our price as 400 plus 20X into 15. Then we get it's equal to 700. Right. Grade 12, let us look at question 10 from our September 2024. And for this question, grade 12, you are given 15 minutes to complete this activity. And your 15 minutes count starts now. Welcome back, grade 12s. Now let us discuss the solutions to the activity question 10.1 and our 10.2. 10.1 says A and B are two events in a sample space where P of A or B is equal to 0,8 and P of probability of B is 0,4. Now they say determine PA if events A and B are mutually exclusive. Now, if the two are mutually exclusive, we are going to say probability of A or B is equals to A, probability of A plus probability of B. Remember, these have A and B. Now, if they are mutually exclusive, we know that P of A and B is equals to 0. So all of this part, it is equals to 0. We're just subtracting with the 0 there. So this is an addition rule that you are supposed to utilize. So for mutually exclusive events, the A and B cannot occur at the same time. Remember, when you look at mutually exclusive events, we are looking at the situation whereby the two events are not having any intersection. So that's why probability of A and B, it is equals to 0. So that's why we are having a formula where from our addition rule, we don't include A and B. Right. Then we're going to substitute in our values. Our probability of A or B is 0,8. It's equals to probability of A plus the probability of B was given as 0,4. Then we can transpose the negative 0,4, or we can subtract 0,4 both sides using the additive inverse. Then we get our probability of A, which is 0,4. Now, let us look at 10.1.2. 10.1.2, it says give us probability of A if A and B are independent events. If A or B are independent events, we are going to say probability of A or B is equals to probability of A plus the probability of B minus the probability of A multiplied by the probability of B. So if they are independent, we are going to place in our values and say our A or B is 0,8. Probability of A is what we are looking for. Our B, we have it, is 0,4. Then our B again, in this case, is 0,4. Then we place our 0,4 there. We solve for probability of A. We get, we can now start by subtracting 0,4 both sides. Then we remain with probability of A is equals to 0,6. Probability of A equals to 0,4. Then from here, we can say probability of A is going to be 2/3. Now, let us look at 10.2 grade 12. Now, 10.2 goes as follows. A medical screening is performed to test for the presence of the disease in a population. The test is not 100% accurate, okay? 10% of those who have a disease will have test negative, and 5% of those who don't have the disease will test positive again. Now, if the test is performed on the entire population and 6,7 test positive, what percentage of the population has the disease? Now let us go back and check our situation here. We're going to populate this into our tree diagram. We are told that 10% of those who have the disease, so we're going to have those with the disease and those without the disease. Then we can say 10% of those who have the disease will test negative, so they can either test positive or they can test negative. Now 10% are testing negative, so 10% is 0,1, so it's going to be 10% here. Then the positive one is going to be 1 minus 0,1, because this is just 100%. So in this case, we are going to have 0,9. They will be positive. That is the first situation. So those who have disease, they can test positive and they can test negative. Now those who don't have disease, they tell us that 5% of those who don't have a disease will test positive. So the 5%, remember it is 0. It's 5 divided by 100, which is equal to 0,05. And 0,05 of those who don't have the disease will now test positive. So this one will be positive. Then the rest of those who don't have disease will test how? Negative. So that means we're going to have 95%, which is 0, or we can say from the 100, which is 1, we minus 0,05, we get the 95, or 0,95. Then 0,95 will therefore have to test negative. Now, as we proceed with our tree diagram, we notice that we were not told how many people are these. So we're going to have them as X, and we're going to have, if this is X and this is going to be 1 minus. So we're not given the totals in this case in terms of the disease percentage and the disease, not disease percentage from the beginning. Right, so that is our tree diagram right there. I hope that makes sense. Then we're going to get our values to say D and P. This is DP, so this one is going to be DN, then it's going to be NDP, not disease negative, positive, and we're going to have no disease negative in that case. So that's our tree diagram. Now let us now look at 10.2. so what I did here, grade 12, with you is the following. We are now going to go and focus our attention to 10.2, and 10.2 we are given 6 marks to complete it. Now let's look at 10.2. Now let's check. The question says, if the test is performed, now we're going to answer the question because the first part we have dealt with it. Now let's answer the question. If the test is performed on the entire population and 6.7% test positive, what percentage of the population has the disease? We are going to look at those that are positive because we are given the 6% which is positive. So we're going to look at anything that has the positive in it. So the positive is here and the positive is here. Because why? The 6.7, it is our positive. So it talks about our positive of the entire population. So we're going to say P, probability of the disease and positive, and the probability of no disease and positive is equals to 0.067. Now wait, let's look at this one. Then the DP is going to be X multiplied by 0.9. So it's going to be 0.9x. Then we're going to look at NDP is going to be 1 minus X multiplied by 0.05. That is the second part there. So that's what we are saying here. We're going to say 0.9x, which is the one of positive and DP, and we're going to have positive and not disease and positive, which NDP, which is going to be this multiplied by that. Then we are going to say it's equals to 0.67. Then we're going to solve for X, distribute the 0.05, we get 0.05 multiplied by 1, we get 0.05, and we get 0.05 multiplied by negative X, we get negative 0.05. Then we can work with the like terms. Our like terms here are those two. We get 0.9x minus 0.05, we get 0.85x. Then we can work with this here and say minus 0.05, we get 0.17. Then our X is going to be 0.2. Then our percentage of the population, because we are not told which is X then, it's going to be 2% of the population has the disease. Right. Now, grade 12, let us look at question 10.3. And for this question 10.3, we have 10.3.1 and 10.3.2. And for these two activities, you are given 6 minutes to complete the two activities. And your 6 minutes starts now. Welcome back, grade 12. So let us look at 10.3.1 and 10.3.2. Now let's look at 10.3. In Free State, the license plates are designed with the 3 letters of an alphabet excluding the vowels next to one another, and then any 3 digits from 0 to 9 next to one another again. Then FX is constant in all the Free State license plates. For example, one of the examples of the license plates we are having is DNV 295 and FS. The letters and digits may be repeated in the number plate. Now let us look at this. This is a very nice activity whereby we are seeing our vehicles or the cars we see in the roads. All of those vehicles we can see they have number plates, and now we can see how many possible arrangements can we make into this number plate. So we understand very well why those automotive industries, they work with the number plates with numbers and letters, because we have more possibilities. But let's look at it. How many unique number plates will be available if the letters and the numbers are not repeated. Now, let's go and collect the data again from our statement. Remember, we have 3 letters. We have, excluding the vowels. Okay. Remember the vowels is I, A, E, O, U is A. This I, A, O, yes. I'm just going to say it like that as an African. Right. One another, and any 3 digits we have numbers from 0 to 9. Right. And they said, on our alphabet, we're excluding our vowels. So we're excluding A. So those are the vowels excluding. So we're excluding those vowels, which is 1, 2, 3, 4, 5. So we are excluding 5 vowels. From how many? From 26 alphabets, we are excluding 5. We are going to work with how many? 21. Now, let us work with this. Letters, there are 3. So we have 3 slots for the letters because we have 3 alphabets. So it's going to be 1, 2, 3. So it's slot 1, 2, 3. And numbers, we have 3 numbers again. So it's 1, 2, 3. So you're looking for the valid number plates if the letters and the numbers are not to be repeated. So no repetition. So we are saying to us, we have the total of 21 because we are saying 21 minus 5, which is the vowel that we took out. Then for the first slot for letters, I can draw 1 letter. I have 21 options. When I draw out 1 letter, how many options do I remain with? 20. Then in the second selection, I take out another letter. I remain with 19. Then that's all. So we have all of those 3. We multiply them together. The numbers again is from 0 to 9. From 0 to 9, we have 10 numbers. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 numbers. For the first slot, to pick up a number, I have all 10 options. If I take out 2, for example, 2 doesn't feature again in the second selection because the letters and numbers are not repeated. Then I will remain with 9 options. After I take out again for the second time, from the 9 letters, I will remain with 8 letters. Then we multiply them together. We get 5,000 or 5,745,600. So those are the number places that are possible where letters and numbers are not repeated. Now, let's look at 10.3.2. Determine the probability that the license plate will start with a 6 and we are keeping the order above. So we are moving from the order of 10.3.1. So we are moving with that order where letters and numbers are not repeated, but we are saying in this case, the number plate will now start with a 6 on the numbers. So we have a change from what we have above. We only change this here. So the first option here, it can only be a 6. So we only take out a 6. From the 10 letters we had, for the second option, we can still have all of other letters excluding the 6. Then you're going to have 9 remaining. Let me repeat that. Remember, for this slot, we can only pick up the 6. And if we take out the 6, that means here, we are going to have 0, 1, 2, 3, 4, 5, 7, 8, 9. We keep the 6 because the 6 was already taken there. That's why we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I take out another one. I'm going to have 8 options in that case. Right. Now let us proceed. We're going to multiply them together. We get 574. Now we are looking for the probability. So when you're looking for the probability, we have to look at the total over the desired outcome. The desired outcome is the one starting with the 6. The total is the one we did on the first question there, which was 505,745,600, and the one that starts with the 6, which is the desired outcome, it is 574,560, which is simplified to 1 over 10. Right. Now this brings us to the end of our lesson, and this is our end of paper 1 revision as we prepare for our trial examinations. Now for our next lesson, we are going to focus on paper 2 revision part 1. We are going to start by looking at statistics, and we will also focus on analytical geometry. And thank you for joining me for this lesson. All the best with your paper 1 examination, and join us again for our next lesson where we start with paper 2. Thank you. Enjoy the rest of the day.